Hello, and welcome to Somniora Mind. I'm glad you're here. Here's a paradox to carry into tonight's drift. The universe is, by every measurement we have, the most violent place that exists. Stars exploding, black holes tearing light apart, entire galaxies colliding in silence. And yet almost everything about it, once you slow down enough to actually look, feels closer to a lullaby than a catastrophe. So here are 3 quiet questions to fall asleep inside of. Why does looking up at the night sky mean looking backward in time, sometimes by millions of years? Why is empty space never actually empty, not even once? And what does it mean that every atom in your body was built inside a star that died before the Earth ever existed? Here's where we begin, with a fact worth sitting inside of. Right now, tonight, photons of light are landing on your eyes that left their source before the pyramids were built, before humans existed at all, in some cases before the Earth itself had finished forming. Let that settle for a moment. You are not looking at the universe as it is. You are looking at the universe as it was. Every star, every galaxy, every faint smear of light in the dark above you is a message sent a long time ago, only just now arriving. Get comfortable. Let your shoulders soften into whatever is holding you. Let your breathing slow into something long and unhurried. And when you're ready, let's drift together through some of the gentlest, strangest facts the universe has to offer. Let's start with light itself, because almost everything else tonight depends on understanding this one quiet truth. Light travels fast, faster than anything else we know of, but it isn't infinite. It takes time to cross distance, even at that tremendous speed. Sunlight leaving the surface of our own star takes a little over 8 minutes to reach your skin. That means if the sun somehow vanished this very instant, you would still feel its warmth, still see its glow, for a little over 8 minutes longer, blissfully unaware that anything had changed. The sky would keep lying to you, gently, for just a little while. Now stretch that idea outward, past our own solar system, into the vast dark beyond. The next nearest star to our sun sits so far away that its light takes a little over 4 years to reach us. Look at it tonight, and you're seeing it as it existed 4 years ago. Look at a galaxy on the far edge of what our telescopes can detect, and you might be seeing light that left its source before our own sun had even finished forming. The night sky isn't a single moment frozen in place. It's a patchwork of different pasts, layered on top of each other, all arriving at your eyes at exactly the same time. There's something oddly comforting in that, if you let it settle slowly. Nothing you see in the sky tonight is happening right now. It already happened. It's already resolved, already finished, already part of the universe's settled history. All that's left is the glow, drifting quietly across the dark, patiently waiting for someone like you to finally notice it. Let's open the second loop now, the question of what fills the space between all of that light. You might picture the space between stars and galaxies as a perfect vacuum, a total absence of anything at all. It's astonishingly close to that, but not quite. Even in the emptiest stretches between galaxies, there are a handful of atoms drifting per cubic meter, an almost unimaginably thin mist of hydrogen, spread so sparsely that it would take enormous volumes just to gather enough to fill a single breath. And running through all of it, silently, endlessly, is the faint afterglow of the very early universe. A gentle bath of microwave radiation left over from a time before stars, before galaxies, before almost anything we would recognize existed at all. It touches every corner of space, including the empty room you might be lying in right now. It has been quietly traveling for over 13 billion years, and it is still arriving. So even the darkest, quietest patch of sky is not actually nothing. It's a thin, ancient mist, laced with light so old it predates every star you've ever wished on. Emptiness, out here, is really just a matter of degree. Nothing in the universe is ever completely alone, not even the space between things. Let's rest inside a slower kind of number for a moment, the sheer scale of what surrounds us. Our galaxy, the Milky Way, holds somewhere between 100 billion and 400 billion stars, depending on how the counting is done. That number is already too large to hold on to meaningfully. But the Milky Way is only one galaxy among hundreds of billions of others, scattered across the observable universe, each one holding its own uncountable population of stars. If you tried to count every star in every galaxy we can currently detect, you would likely be counting somewhere in the range of many billions of billions, a number so far past ordinary experience that it stops feeling like a quantity and starts feeling more like a kind of texture, a background hum of scale that the mind simply learns to accept rather than fully picture. And yet, from the ground, on a clear night, away from the glow of any city, the unaided human eye can typically make out only a few thousand individual stars at once. A few thousand, out of that entire staggering multitude. What you're seeing with your own eyes is a whisper of a whisper of a whisper, the barest, faintest sliver of everything that's actually out there, glowing in every direction, forever. There's a kind of relief hidden in that thought, if you let it be one. You were never meant to hold the whole universe in view at once. Nobody was. Not even our most powerful instruments come close. We were only ever meant to catch small, quiet fragments of it. A few thousand points of light on a clear night, a handful of facts before sleep, a small glimpse of something enormous, offered gently, a little at a time. Now, let's talk about where the atoms in your own body actually came from, because this is one of the strangest, gentlest facts the universe has to offer. The very early universe, in its first few minutes, produced almost nothing but hydrogen and helium, the simplest possible elements, light and plane. Nothing more complex existed yet. No carbon, no oxygen, no calcium, no iron, none of the heavier building blocks that make up rock, water, or living things. Those elements had to be made somewhere, and the only furnaces hot enough and patient enough to make them were stars. Deep inside a star's core, under crushing pressure and extraordinary heat, hydrogen fuses into helium, and over the star's long lifetime, heavier elements slowly build up in layers, one nuclear reaction stacked carefully on top of another. When a massive star finally reaches the end of its life and explodes as a supernova, all of that hard-won material, carbon, oxygen, nitrogen, calcium, iron, gets hurled outward into space, seeding the surrounding darkness with the raw ingredients for everything that comes next. New stars form from clouds enriched by that scattered material. New planets form around those stars. And eventually, on at least one of those planets, some of that stardust arranged itself into oceans, into forests, into the very particular pattern currently reading these words. So it isn't only poetic to say you're made of star stuff. It's simply, plainly true. The calcium in your bones, the oxygen in your lungs, the iron carried in your blood, all of it was forged inside a star that lived and burned and eventually died, long before the Earth ever existed. You are, quite literally, the patient, generous afterlife of a star. Let that settle gently as you breathe. You are not separate from the universe, looking up at it from the outside. You are one of its outcomes, one of its quiet, unhurried creations. Let's open the third loop now. The question of just how strange the emptiness between galaxies really is, and what waits at the very edges of what we can even see. The observable universe, the portion we can actually detect, limited by how far light has managed to travel since the beginning of everything, stretches about 93 billion light-years across. That number sounds almost like a typo next to the age of the universe itself, a little under 14 billion years old. How can a 14 billion-year-old universe let light travel across 93 billion light-years of space? The answer is that space itself has been quietly stretching this entire time, carrying distant galaxies farther away even as their old light continues traveling toward us. The universe isn't just old. It's been patiently expanding the whole time, gently widening the room around everything inside it. And beyond that observable edge, the region we simply cannot yet see, because light from it hasn't had time to reach us. There is very likely more universe still, possibly a great deal more. Possibly, according to some models, unimaginably more. We are not looking at the edge of everything that exists. We are only looking as far as 13.8 billion years of travel time has allowed light to carry news to us. Somewhere beyond that boundary, more galaxies are almost certainly turning slowly in the dark, their light still centuries, millennia, or eons away from ever reaching anyone here. There's something both humbling and quietly soothing in that thought. We will never see all of it. No one ever will. And that's all right. The universe was never going to fit inside a single lifetime, a single mind, a single glance upward on a clear night. It only ever asks you to notice the small, arriving fragment in front of you, and let the rest remain, patiently, exactly where it is. Let's drift for a while through the quiet mathematics of the sky, because even something as simple as starlight carries more structure than it first appears to. When you look at a star and notice it twinkling, what you're actually seeing has almost nothing to do with the star itself. Stars, from this distance, shine with an extraordinarily steady light, barely flickering at all. The twinkle happens much closer to home, inside our own atmosphere, as pockets of air at slightly different temperatures and densities bend that starlight just slightly, over and over, on its way down to your eyes. A star's light travels in a perfectly straight, calm line for possibly thousands of years, undisturbed by anything at all, only to spend its very last fraction of a second being gently jostled by the restless air just above your head. The twinkle isn't the star being unsteady. It's the last few miles of an impossibly long journey, finally meeting a little turbulence right at the very end. There's something worth resting on in that. So much of the journey, calm and steady. Only the final moment, close to arrival, a little uneven. Planets, by contrast, don't twinkle nearly as much because they're close enough and appear large enough in the sky that the tiny atmospheric shimmer mostly averages itself out across their visible disk. Stars are single points of light, vulnerable to every small ripple in the air. Planets are wide enough to shrug most of it off. Maybe that's worth remembering too, in whatever way feels useful tonight. Sometimes it isn't the length of the journey that unsettles something. It's simply how narrow, how exposed, how single-pointed it happens to be, right at the very end. Let's talk for a while about the moon, since it's one of the very few cosmic objects most of us have actually watched change, night after night, with our own eyes. The moon doesn't produce any light of its own. Every soft glow you've ever seen coming from it is simply reflected sunlight, bounced off its pale, dusty surface and sent back down toward Earth. And the moon is drifting away from us, very slowly, at a little under 2 inches every year, as the gentle pull of tides between Earth and moon exchanges energy and gradually widens the gap between them. It's much too slow to ever notice within a single lifetime, or 100 lifetimes. But billions of years from now, the moon will hang smaller and more distant in the sky than it does tonight, pulling less strongly on our oceans, taking slightly longer to complete each orbit than it does now. There's a strange, tender comfort in that kind of change, so slow that it's essentially invisible, yet entirely real, continuing quietly whether or not anyone is paying attention to it. The moon above you right now is very slightly farther away than it was for the ancient astronomers who first mapped its phases, and very slightly closer than it will be for whoever happens to look up at it a million years from now. Nothing about it needs to happen quickly to still be happening. Let that thought settle the way moonlight settles across a dark room. Softly, gradually, without demanding to be noticed all at once. Let's rest for a while longer on the rings of Saturn, because they carry a very particular, very fragile kind of beauty. Saturn's rings aren't solid at all. They're made of an enormous number of individual chunks of ice and rock, ranging from tiny grains to pieces the size of a house, each one quietly orbiting the planet on its own path, held loosely together by gravity into what looks, from a great distance, like a single smooth, solid band. Up close, it would look more like a slow, endless snowstorm, drifting gently around the planet in a wide, flat disk, catching sunlight in soft, pale shades. And the rings are surprisingly thin, in places, only about 30 feet or so from top to bottom, an almost impossibly delicate structure compared to the tens of thousands of miles the rings stretch across. There's something almost meditative in picturing that. An enormous, glowing structure, visible from Earth with even a modest telescope, made not of one solid thing, but of countless small, separate pieces, each one drifting patiently along its own quiet path, and yet together forming something whole, something beautiful, something that has held its graceful shape for a very long time. Maybe wholeness doesn't always require a single, solid piece. Sometimes it's simply many small, separate things, drifting gently together in roughly the same direction, patient enough to let a shape emerge on its own. Let's turn towards something a little more mysterious now, the very faint, very old signal that first told us how the universe actually began. Scattered evenly across the entire sky, in every direction you could possibly look, there is a faint bath of microwave radiation left over from a time when the universe was still impossibly hot, dense, and only a few 100,000 years old, a time before stars, before galaxies, before light itself could travel freely through space without being scattered by dense, hot particles. As the universe expanded and cooled just enough for light to finally travel unobstructed, that ancient glow was set free, and it has been drifting through space ever since, stretching and cooling alongside the universe itself, until it settled into the faint microwave hum we can still detect today, in every direction, all these billions of years later. It's sometimes called the afterglow of creation, and it's remarkably, almost eerily uniform. Nearly the same temperature no matter which direction you measure it from, varying by only the tiniest fractions of a degree from one patch of sky to another. Those tiny variations, subtle as they are, mark the first faint seeds of structure in the universe, the earliest, gentlest beginnings of what would eventually grow into galaxies, clusters, and everything else that followed. In a very real sense, this scattered whisper of ancient light is the oldest baby picture that exists of anything at all, and it's still arriving, quietly, every single night, whether or not any instrument happens to be listening for it. Let's pause here for the tagline that's become a little ritual of its own on this channel, because if any of this is helping your mind unwind tonight, and you'd like more of these slow drifts through the strange and the vast, you're welcome to stay a while longer or come back another night. One quiet mind at a time. That's really all this is for. Now, back into the dark. Let's talk about time itself for a while, because out here, it doesn't behave quite the way it feels like it should. Close to a very massive object, a black hole, a dense neutron star, anything with enormous gravity, time actually passes more slowly than it does farther away. This isn't a metaphor or a rounding error. It's a measured, tested feature of how gravity and time are woven together. A clock placed near a strong gravitational field genuinely ticks slower than an identical clock placed somewhere calmer. Even here on Earth, a clock at sea level ticks very slightly slower than a clock on a mountaintop because it sits a little deeper in our planet's own gentle gravitational L. The effect is tiny at Earth's modest scale, but it's real, and it has been measured directly again and again. Now imagine that same effect, turned up to its most extreme version, near the edge of a black hole. Time there would crawl to something almost unrecognizable compared to time far away. An object falling toward a black hole would, from a distant observer's perspective, appear to slow down more and more as it approached the edge, its light stretching and dimming, seemingly frozen there forever, even as, from its own perspective, it continued falling through completely ordinary time. Two truths, both accurate, depending entirely on where you happen to be standing. There's something worth resting inside of in that idea. Time was never one single, universal rhythm ticking identically everywhere. It bends, it stretches, it moves differently depending on how much mass happens to be nearby. Even the steady, comforting tick of a clock is, in its own quiet way, a local opinion rather than a universal fact. Let's drift towards something gentler now. The slow, unhurried lives of the coolest, dimmest stars in the universe. Not every star burns bright and fast. The largest, most massive stars live short, dramatic lives, burning through their fuel in only a few million years before ending in violent supernovae. But the smallest stars, the faint red dwarfs that make up the majority of stars in the universe, do the opposite. They burn their fuel so slowly, so conservatively, that some of them are expected to keep shining for trillions of years, far longer than the current age of the universe itself, many, many times over. Not one of these smallest, dimmest stars has ever died of old age, anywhere, in the entire history of the cosmos so far. There simply hasn't been enough time yet. Think about the patience embedded in that fact. Somewhere out there, quiet red stars are glowing right now that will still be glowing long after every bright, dramatic star you can currently see has long since faded and gone dark. Long after the Milky Way itself has merged with its neighbors and reshaped into something unrecognizable. Long after almost everything else in the sky has changed beyond recognition, these small, dim, patient stars will likely still be exactly where they are, burning gently, in no rush at all. Let your own breathing match that rhythm for a moment. Slow, steady, in no rush to be anywhere else. Let's turn now toward the sheer, quiet strangeness of black holes, not as violent monsters, but as something closer to a very deep, very patient kind of silence. A black hole forms when an enormous amount of mass gets compressed into an extraordinarily small space, creating gravity so strong that nothing, not light, not matter, not even information as we understand it, can escape once it crosses a certain boundary, called the event horizon. From the outside, a black hole doesn't look like a swirling, violent void. In the absence of nearby material falling into it, it looks like almost nothing at all, a perfectly dark, perfectly still region of space, silently bending the light of everything around it. And at the center of nearly every large galaxy, including our own, sits a supermassive black hole, an object millions or even billions of times the mass of our sun, quietly anchoring the gravitational structure of its entire galaxy from the middle, mostly dormant, mostly silent, doing very little of anything most of the time. Our own galaxy's central black hole spends the vast majority of its existence simply sitting there, calm, dark, largely undisturbed, while hundreds of billions of stars, including our own sun, quietly orbit around it once every couple 100 million years. There's a strange comfort in imagining that. At the very center of the galaxy that holds your entire solar system, there is a vast, ancient, extraordinarily patient darkness, holding everything gently in its gravity, asking for nothing, disturbing almost nothing, simply waiting there, the way it has for billions of years, and the way it likely will for billions more. Let's slow down further and consider the quiet, ongoing motion underneath everything you've been imagining tonight. Nothing out here is actually still, even when it looks that way. The Earth is spinning, carrying you around its axis at roughly 1,000 miles an hour, though you feel none of it. At the same time, the Earth is orbiting the Sun at almost 70,000 miles an hour. And the Sun itself, along with the Earth and everything else in our solar system, is slowly orbiting the center of the Milky Way, completing one full loop only once every 225 to 250 million years or so, meaning the very last time our solar system was in this exact position around the galaxy, dinosaurs had not yet appeared on Earth. You are, in other words, moving at extraordinary speed in several directions at once, all the time, and you have never once felt any of it. There's something worth holding on to in that. So much motion, so much velocity, and from where you're lying right now, it feels like perfect stillness. Maybe that's worth remembering the next time your own mind feels like it's racing too fast to rest. Even inside tremendous, continuous motion, stillness is still possible. It's simply a matter of perspective and of trusting the quiet part of the ride. Let's talk gently now about galaxies colliding, because even that sounds far more violent than it actually is. Our own Milky Way is, very slowly, on a collision course with our largest nearby neighbor, the Andromeda Galaxy. In several billion years, the two galaxies are expected to merge into one larger structure. It sounds catastrophic, described that way. But here's the strange, quiet truth underneath it. Even in a collision between two galaxies, each containing hundreds of billions of stars, the space between individual stars is so vast that the likelihood of any two stars actually colliding with each other is remarkably small. Two galaxies can merge into one single, larger galaxy, reshaping entirely over millions of years, and almost no individual star within either one ever actually touches another. It's less like a car crash and more like two enormous, slow-moving clouds of fireflies drifting through each other in the dark, countless individual lights passing near one another, rearranging themselves gradually into a new shared pattern, without ever really colliding at all. Even the most dramatic events in the universe, up close, often turn out to be gentler than their description suggests. Distance, it turns out, has a way of protecting almost everything. Let's rest for a while on the birthplaces of stars themselves. Enormous clouds of gas and dust scattered throughout galaxies, called nebulae. Inside these vast, cool clouds, gravity slowly gathers material together, clump by clump, until dense pockets form dense enough and hot enough at their core to ignite nuclear fusion, and a new star is born. This process can take millions of years, unfolding at a pace almost too slow to describe as motion at all. And it is, in its own way, happening constantly, in various corners of every galaxy, including our own. Stars are being born somewhere in the Milky Way tonight, in the same unhurried, patient way they have been for billions of years, in clouds so large that a single one could contain the raw material for tens of thousands of new stars. There's something soothing in imagining those nurseries, vast, cool, dim clouds, quietly incubating new light, taking their time, never rushing the process, patiently waiting until conditions are exactly right before letting anything ignite. Maybe that's a useful image to borrow for yourself tonight, if your own mind still feels like it's holding on to something. Not everything needs to happen quickly. Some of the most enormous, beautiful things in existence take millions of years to become anything at all, and the waiting itself is simply part of how they're made. Let's drift toward the very edges of understanding now, gently, without needing to resolve anything. Roughly 70% of everything in the universe appears to be something scientists call dark energy, a mysterious force causing the expansion of the universe to accelerate over time, pushing galaxies apart from each other a little faster with every passing age. Roughly another 25% appears to be dark matter, an invisible form of matter that doesn't interact with light at all, but whose gravity still shapes how galaxies hold themselves together. That leaves only about 5% of the universe made up of the ordinary matter we can actually see and touch: stars, planets, gas, dust, and everything you have ever known or loved. Sit with that for a moment. Nearly everything that exists is still, in some sense, a mystery, quietly surrounding the small, familiar 5% we've managed to understand. And somehow, that doesn't feel frightening, does it, at this hour, in this quiet? It feels almost like permission. You don't have to understand everything to rest peacefully inside of it. The universe itself doesn't fully understand 95% of what it's made of, and it keeps turning anyway, patiently, without needing an answer first. Let's rest for a while on the strange, quiet idea of gravitational waves. Ripples in space itself, set loose by some of the most violent events the universe has ever produced, yet arriving here, at the end of their long journey, as almost nothing at all. When two black holes spiral into each other and merge, far away, in some distant corner of the universe, the collision doesn't just release light or heat. It sends a ripple through the very fabric of space itself, stretching and compressing distance by an infinitesimally tiny amount as the wave passes through. By the time that ripple reaches Earth, after traveling for possibly over 1 billion years, its effect is so faint that detecting it requires measuring a change in distance thousands of times smaller than the width of a single proton, across instruments miles long. And yet, we have detected it, multiple times, a genuinely violent event from an unimaginable distance, arriving here as the gentlest possible whisper, so faint it took over a century after it was first predicted before anyone managed to build something sensitive enough to feel it at all. There's something worth carrying into sleep in that image. Even the most catastrophic, cataclysmic event imaginable, stretched across 1 billion years of travel and distance, arrives here so softly it barely disturbs anything at all. Distance and time, it turns out, have an extraordinary capacity to gentle almost anything down into something quiet, something small, something you would need to listen for very, very carefully in order to even notice it happened. Let's drift for a moment toward the question of just how much room the universe actually has for other worlds like our own. Just in our own galaxy, current estimates suggest there could be tens of billions of planets sitting in what's sometimes called the habitable zone, the particular range of distance from a star where conditions might allow liquid water to exist on a planet's surface. That's just one galaxy, among hundreds of billions of others, each one likely holding its own enormous population of planets, many of them sitting in similarly gentle, tempered orbits around their own stars. We haven't found evidence of life anywhere else yet, but the sheer, quiet scale of how many places could plausibly hold it is almost impossible to hold in your mind all at once. Maybe that's a comforting thought to drift on tonight, rather than an unsettling one. Somewhere out there, across all of that scale, there may be countless other quiet nights unfolding right now, on countless other worlds, under skies none of us will ever see. Other version of stillness, other versions of rest. You are not the only small, warm thing settling down for the night somewhere in this enormous, patient universe. You're simply the one having this particular thought, in this particular moment, under this particular sky. Let's linger a while on color, because even that turns out to be a kind of message quietly encoded into starlight. A star's color isn't decoration. It's temperature written in light. The coolest stars glow a soft, deep red, burning at a few thousand degrees. Slightly hotter stars, like our own sun, shine a warm, familiar yellow-white. Hotter still, and a star turns a piercing blue-white, burning at tens of thousands of degrees, spending its fuel so quickly that it rarely lives more than a few million years before ending, often violently. In other words, a star's entire life story is quietly written into its color, if you know how to read it. Blue means young, hot, and short-lived. Red often means old, cool, and patient, having already burned through the more dramatic chapters of its life. There's a strange comfort available in that idea, if you let it settle. The most urgent, intense, blazing lights in the night sky are often the ones living the shortest, fastest lives. The soft, dim, reddish ones tend to be the ones built for patience, quietly enduring for far longer than almost anything else out there. Maybe that's worth remembering the next time something in your own life feels like it's burning a little too bright, a little too fast. Slower, softer, and quieter isn't a lesser way to shine. Out here, it's often the way that lasts the longest. Let's rest for a while on the sun itself, since it's the one star close enough to actually feel. Our sun, an entirely ordinary, unremarkable star by galactic standards, converts about 600 million tons of hydrogen into helium every single second, releasing the energy that eventually reaches us 8 minutes later as warmth on skin and light in the sky. It has been doing this steadily for about 4.5 billion years, and it has enough remaining fuel to continue for roughly another 5 billion years before its own story changes shape entirely. Every single day of your life, without exception, has been quietly powered by a nuclear reaction happening 93 million miles away, arriving gently enough to grow plants, warm oceans, and let you fall asleep tonight without a single conscious thought about where any of that heat actually came from. There's something worth resting inside of in that. An event violent enough to be almost impossible to picture, happening constantly, every second, without pause, and yet the only thing it asks of you, all the way out here, is that you let it warm your face for a while, and otherwise go on with your day entirely undisturbed. Maybe the biggest, most powerful things don't always need to announce themselves loudly. Sometimes they simply arrive as warmth, softly, at the end of a very long journey, asking nothing else of you at all. Let's drift for a moment toward the very shape of space itself, because even that turns out to be gentler and stranger than it first sounds. Space isn't simply an empty stage that things happen inside of. According to our best understanding, space itself can bend, stretch, and curve in the presence of mass, a concept that still startles people the first time they really sit with it. A massive object, like a star or a black hole, doesn't just pull on things around it the way an old-fashioned magnet might. It actually curves the surrounding space, so that anything moving nearby follows the natural curve of that bent space, which we experience from the inside as gravity. Light itself follows those same gentle curves, bending its path around massive objects in a way that has been measured directly. Watching starlight subtly shift position as it passed close to the sun during a solar eclipse, exactly as predicted. It's a strange thing to imagine, drifting towards sleep. The space around you, right now, wherever you're lying, is very slightly curved by the presence of the earth beneath you, by the mass of your own body, by the walls and furniture and quiet air of the room around you, all of it bending space by an amount too small to ever notice, but real nonetheless. You are not simply resting inside space. In some small, quiet way, you are shaping it too, just by being here, however briefly, however gently. Let's rest for one more moment on the idea of silence itself, because space, in its own strange way, is the quietest place that exists. Sound needs something to travel through: air, water, some kind of physical medium for the vibration to move across. Space, being almost entirely empty, carries almost no sound at all. An explosion powerful enough to outshine an entire galaxy for a brief moment would still, technically, happen in complete silence, at least as far as anyone floating nearby, without a spacecraft around them, would ever be able to hear. All of the dramatic, violent imagery we associate with space, roaring explosions, rumbling collisions, is really something added afterward, translated into sound for our own benefit, because the universe itself simply doesn't work that way. Out there, the most extraordinary events in existence occur in perfect, absolute silence. There's something almost restful in imagining that. Somewhere out past the edge of our atmosphere, entire stars are dying, entire galaxies are colliding, in complete and total silence, simply because there's nothing there to carry the sound. Maybe that's a comforting image to hold on to as you drift off tonight. A universe so vast, so full of enormous events, and yet so profoundly, permanently quiet, everywhere except the small, warm, sound-filled pocket of atmosphere you happen to be resting inside of right now. Let's spend a little more time with the stars overhead, because even a familiar constellation is stranger than it first appears. When you trace the shape of a constellation with your eyes, you're not actually looking at a group of stars that live anywhere near each other. Most constellations are optical illusions of a sort, stars that happen to line up from Earth's particular point of view, but that might sit at wildly different distances from us in reality, some far closer, others many times farther away, only appearing to belong together because of the angle we happen to be viewing them from. Two stars that look like close neighbors, forming a corner of some familiar shape, might actually be separated by hundreds of light years of empty space between them, each one entirely unaware of the pattern its light happens to be helping draw from this one particular vantage point, so many years later. It's a gentle reminder of how much of what we see depends on where we happen to be standing. Travel far enough away, in any direction, and every constellation you've ever recognized would slowly warp and dissolve into an entirely unfamiliar arrangement, because the underlying stars were never truly grouped together to begin with. The patterns exist because of us, not because of any real bond between the stars themselves. And somehow, that doesn't make them any less beautiful. If anything, it makes them a little more personal, a shape built quietly between the universe and whoever happens to be looking up at exactly the right angle to notice it. Let's rest for a moment on the idea of an entire galaxy, seen not up close, but from very, very far away. If you could somehow travel far enough outside the Milky Way to see it whole, you would likely see a vast, softly glowing spiral, arms of stars curling gently around a dense, bright center, the whole structure spanning roughly 100,000 light years across, and yet, from a great enough distance, looking as delicate and quiet as a single snowflake drifting through the dark. Every star you've ever known, every planet, every person who has ever lived, would be contained somewhere within that one soft spiral of light, indistinguishable from any other point within it, a single mode of brightness lost gently among hundreds of billions of others. There's a particular kind of peace available in imagining that view. From close up, life feels enormous, individual, deeply significant, and in every way that matters to you personally, it still is. But from far enough away, everything you've ever worried about, everything you've ever loved, exists as an infinitesimally small part of one soft, glowing arm on one ordinary galaxy, among countless others scattered gently through an endless dark. That distance doesn't erase meaning. It just quiets it, the way distance quiets almost everything eventually, softens the edges, lets it rest. Let's think, for a little while, about how the universe actually began, as gently as that subject allows. The best current understanding suggests that everything, all of space, all of time, all of the matter that would eventually become every star and every galaxy, began expanding outward from an extraordinarily hot, dense state, nearly 14 billion years ago, in what's usually called the Big Bang. It wasn't an explosion happening inside of space, the way an explosion happens inside a room. It was the beginning of space itself, expanding outward in every direction at once, with no center, no edge, no single point you could travel back to and stand inside of. Every point in today's universe, including the one you're resting in right now, was once, in some sense, at the very center of that beginning. That's a strange thought to end on, but a quiet one, if you let it be. You are not simply located somewhere within the universe, some small distance away from where everything began. In a very real sense, you are standing exactly where it all started, because everywhere is where it all started. The beginning of everything isn't a place you're far away from. It's a moment you're still gently, slowly, unfolding out of, along with every star, every galaxy, and every quiet night sky that has ever existed since. Let's slow all the way down now and gather the picture we've built together tonight. We began with light that left its source long before it ever reached you, carrying old news gently across the dark. We found that empty space was never quite empty at all, laced everywhere with a faint, ancient glow older than any star. We remembered that every atom inside you was forged inside a star that burned and died long before Earth existed, making you, quite literally, the patient afterlife of something enormous. We wandered past the edges of what we can even see, past black holes holding vast, calm silences at the centers of galaxies, past small dim stars destined to outlive nearly everything else in existence, past galaxies drifting slowly toward each other without ever truly colliding. And underneath all of it, the same soft rhythm kept returning again and again. Patience, slowness, enormous processes unfolding over millions or billions of years, never rushing, never needing to. The universe does not hurry. It never has. It simply continues, gently, one quiet unfolding at a time, whether or not anyone happens to be watching. Maybe that's the feeling worth carrying with you into sleep tonight. That you, too, don't need to rush anything right now. Let your thoughts slow the way starlight slows across unimaginable distance, arriving softly, long after it began its journey. Let your body settle the way gas settles quietly into a new star, unhurried, patient, exactly on its own time. There is nowhere you need to be right now except here, resting, made of the same old light and the same old patience as everything else out there in the dark. Rest now. You've earned it. Good night.